All right, so today we're going to look at performing a regression analysis. So this is where we're going to have, we're going to go through the whole process of when we've got the bivariate data when it's two numericals, and we do one of these regression, meaning a least squares regression line, that line of best fit. So the first thing when we do, and we've already seen this, like we get our two pieces of data and we create a scatter plot. So we know with our scatter plot, we're putting our response variable there and our explanatory variable along there. We then so we've got our scatter plot created. We then might get our R value and we'll comment on the strength. So if we had to do a whole analysis on a whole set of data, this is what we're going to do. So we then calculate the R in our calculator and comment on the strength. Then we might write the equation out. So we've got to calculate using our calculator and the lists, and we'll do this in a minute. We're going to calculate the A and the B value and write the equation out. Then the next thing is we're going to see is this interpreting the coefficient of these. So the coefficient, the slope and the intercept, they're talking about we're going to interpret this A value and B value. And there's little statements that I've got, because remember when I said whenever you have an interpret, I'll have a statement that you fill in, and you just have to fill it in according to our example. So we'll show you that. We'll have a look at that. Then we use this equation to make predictions. So we've got, like say before, we've got our height and weight formula. So we've got a formula to predict weight using height. So we might ask if we had someone like this height, what weight would we expect? And so they're predictions. We'll then look at the R squared, which we've already done. And we'll write that interpretation statement to explain what that tells us. And then our last one, because if you remember that we always assumed that it was linear. So we finally can learn how to do, there's a test that we can do, and it's called the residual plot, and I'll show you how to do that. And that will prove whether the data is actually following a linear pattern or if it's not, okay? So when it says write a report on your findings, we are just probably going to do all these things in dot point and step it through. And that it's the same on the SAC and the same on the exam. They'll just ask you bit by bit to do these separate things. All right, so we've got this example in your notes, and we're going to do this on the calculator together. So I'm actually going to stop and flick over to our calculator. And so we're going to enter these data in, boys. So let's enter in birth rate per 1,000 and life expectancy in years and type them into your calculator. So on this scatter plot, we can see, because they've got 0 here, that is the y-intercept, yeah? Over here, this is not 0, and that is why this is not showing the correct intercept. Okay, now we're up to interpreting the coefficients. So the coefficients are that A and B. So if you need to write it, the A and B values, that's what we're interpreting. So the slope is the B and the intercept is the A. So first of all, we're going to interpret our slope for this question. So if you've got a positive or a negative, you have to choose. And we've got a negative, so this is the one I'm going to write in. I'm pretty sure in your notes it's yellow on the fill-in blank part. So and see here it's telling me to write the response variable. So I'm going to say the life expectancy decreases by, and I'm going to say, now it's telling me to put the B value, so I'm going to say decreases by 1.44. Now it wants me to put the RV units, which life expectancy is years. When the EV, which was birth rate, increases by 1, and I'm going to write the units, which was per 1,000, one birth, sorry, rub that out. 1 birth per 1,000. Okay? Go on. So if we're asked to interpret the A value, we're going to write this. Now the A value for us in this example was the 105.37. So we'd write this statement. We go, the regression line intercept, or the y-intercept, predicts the, and I'm going to pop in what the RV was life expectancy to be, and I've got to put 105. I'm just going to round because it's years. 105 years when the birth rate per 1,000 is 0. Okay? So only in those yellow bits is where you're writing the thing. So down here, you've got written that whole statement, which we would have used those blank templates to write. And there you go. We've written it down there. All right, so now we're on to the coefficient of determination. So that's found back on our calculator. We can see we should be on that page. And what's the R squared? I've got it as 0.65. Yeah, 651. So here's what the R squared is. Now remember, we changed that. This, how to interpret the R squared, is back a few pages in your booklet. But we wrote, it says the coefficient of determination tells us that, and this is what you had to change. You had to write the R squared in a percentage, so I've times it by 100. So 65.1% of the variation in life expectancy can be explained by the variation in birth rates. There were the things you had to fill in. We've already got a fill in the blank. All right, so because it's 65, we're saying it is fairly significant, because I said anything more than 30%, we're going to say it has some significance. All right, so we're saying if there's the birth rate is having some, maybe in this data, the birth rate is affecting the life expectancy in the countries. Okay, the next thing we'll get asked to do is make predictions. So we're going to use this equation that we had. So I'm just going to write it out. So we had this equation that we had. We had life expectancy equals 105. I'm going to round to one decimal place now for that. Minus 1.44 times, I'll do 0.4, times birth rate. Okay, so they've asked you, what is the life expectancy of a country with a birth rate of 35? So they're asking per 1,000 people. So they're asking you to predict what that is. So you can see we are popping the 35 into the birth rate because that's given. And we said, all right, so the country that gets 35 births every 1,000, they're expected to live to 55 years, a life expectancy. That's what our thing. So there's a little statement. You don't ever really have to write out a statement. They'll just ask you to predict. Now, the next thing is they're going to ask you whether your prediction was interpolating or extrapolating. So interpolation, so inter means you're predicting within your, if you think of your EV or your X values, it's a number in between your lowest and your highest. So if you look here, 26 was about my lowest one, and up here I'm going to say about 43. So any prediction values in here is interpolation. Now, if you predict, so is 35 interpolation? Yes, yes. If I predict outside here, outside this way, so less than 26 or more than 43, that would be extrapolating. And why do we need to do that? Because things can suddenly change once you hit a certain target. So we shouldn't assume, and when you're presenting your data, when people would be presenting this data, you can only go on what we've seen. So we go, we've only seen this, a country is between here and here, so we're going to say, so when they ask you, oh, what about a country of 60? We can give them a prediction, but we're going to say, look, that's extrapolating. We haven't really tested out in that area, so that's why we do it. You will just get asked, are you inter or you're extrapolating? So you have to look for your lowest and highest explanatory variable number. So it's the X values, okay? So then we're now up to a residual plot. And if you remember back to with the scatter plot, remember I said we have a scatter plot, and then I said when we do this least squares regression line, they take into account this residual. So the residual is the distance between the data value and the predicted value. What we do is we can create a residual plot. So what a residual plot is for every one of those explanatory variables, so all the EVs are still down here, we've calculated that distance and we've put a residual, and we've calculated and we've said what the distance is between what was actual and what was predicted. So if you're on the line, you'd have a residual of 0, yeah? Because you're spot on. There's no distance between the dot. If you're under the line, you'll have a negative residual because the data was lower than what was predicted. So down here will be negative residuals if you're under the line, and up here would be positive residuals because your data is actually more than the predicted, the line. So what you see in a residual plot, you see this 0 line because we have net up here, sitting up here because we have positive and negatives. So I'm going to pause it here. I'm going to show you how to do a residual plot on the calculator. Let's go back to here. They can ask you to work out individual residuals, so that little distance between. So remember the formula for residual written here is the actual value minus the predicted. So they've asked us to, the country labelled A on the scatter plot has a birth rate of 34. So this was an X value or an EV value, yeah? And a life expectancy of 66 years. So that was the RV and that is the actual. So that was the actual. Now, residual is the difference in the RV values. So I've got the actual here. So you can see we're going to do 66. But now I need the predicted. So I'll use the equation. So we popped 34 because that's the X value. And we found out that was the predicted. And then we get the residual. So it was, for this country, it was like 9.6 years off. So the actual was a bit higher than the predicted because it's positive. Okay, and then down here, we do an example of a negative one because the actual was 49. So we could have gone to, they said for the country with 34. So they've gone, there was actually 2 of them, 2 countries with 34. So we're still using the same predicted, but that country only actually had a life expectancy of 49, and so their residual was negative. All right? So when we do a residual plot, why we do a residual plot like this is we're testing to see if it's linear. So what they often say, you're testing because we've assumed it's linear, so the assumption. Now, you have to be, it's a little bit tricky. When the residual plot shows no pattern, so can you see here, there's no pattern, it's all random scatter. When it's random scatter, it is linear. So from the residual plot, you can see here, from the residual plot, we said no clear pattern in the residuals, and this confirms our assumption that it is linear. So if it is random, the residual plot, you'll say it's linear. If we went to the next one, or I can't. If you see what you'll see, in chapter 5, we're going to see there'll be a pattern in the residual plot. So I don't have one here. Anyway, what you'll see is this residual, say you have a residual plot, and that's, I'm going to call that the 0 line. Yeah, you see the dots do something like that. Yeah, you see like that they follow a line or something, but we'll look more into it. But at the moment, they're most likely going to be random, and we're going to say yes, it was linear. So